Hi friends, today we're talking about finite and infinite sets, memberships in a set, and rearranging before graphing. Let's get started. This is lesson 56, Algebra 1 for Saxon, 3rd edition. All right, so a finite set looks like this. It's a group of numbers and it's closed brackets. It's just this. A finite set includes 6, 7, 8, 9, and 10 in this particular set. An infinite set includes these 3 dots at the end, 1, 2, 3, and so on and so forth, infinite number of times, right? So let's do this. Number 1 says represent the following as set K. So the way that you would do that is say, all right, we've got K. I just want to make sure that they've got this. Okay, so the way we would say that is you always want to put it in order. So we'd say K equals, and we use these little brackets here, and we would say 0 and 1. Now, even though 0 and 1 are both listed twice, you only write them down 1 time. So then we have 2, and then we have 4, 5, and 7. So there you go. That's all you have to do. The set K contains 0, 1, 2, 4, 5, and 7. All right, so for our next one, we've got represent the following as a set L. So same idea. We're going to say L equals, we use our little bracket there. We want to go in order. So negative 13, I see that guy lingering. And then 0. Then 1. Then 7, 8. And then we have 15 and 42. And again, even if a number is listed more than 1 time, you just write, if it's listed 2 or 3 times, you just list it that 1 time in the set itself. All right, some notes to take down. When it looks like this weird E, that means it includes. If it's the weird E with a line through it, it does not include. Does not include. So let me write that down again. We've got includes and does not include. So what does that mean? Well, when we look at example number 3 here, we want to see if these are true or false. So what this is asking us for A is 5 included in A? So we come up to A, I see 5, so this would be true. Is 4 included in C? No, so it's false. Is 5 not included in B? That is true, because there's no 5 in B. Okay, let's try this one. True or false again. Is 6 included in L? It is not, so this is false. Is 0 included in N? It is, so this is true. Okay, so that's all you need to know about sets for right now. The next thing that we are going to do is graphing. So if you don't already have it, make sure you grab your graph paper. Graph 3x plus 2y equals 4, but you need to solve for y first. So we have 3x plus 2y equals 4. To solve for y, we're going to minus 3x from both sides first. Now remember, when you do 4 minus 3x, that's not 1x. You cannot combine those. Those are not like terms. So we say 2y equals, and to start getting in the habit of putting it in slope-intercept form, you're going to want to put the chunk with the x first. So really what this is 4 minus 3x, like that. But I actually want to rewrite this so that it's 2y equals negative 3x plus 4. See the difference? They're the same thing. However, putting that chunk with the x first will really help when it comes to solving these when we get to graphing them in slope-intercept form. Now, to get that y by itself, we're currently multiplying. Opposite of multiply is divide. So when we do that, we get y equals negative 3 over 2x plus 2. So now it's asking us to plug these different ones in there. 0 is fairly easy because if I do that, y equals negative 3 over 2 times 0 plus 2. 0 times anything is 0, so that goes away. So y equals 2. Now let's do it. Y equals negative 3 over 2 times 2 plus 2. Remember, you can turn anything into a fraction by putting it over 1. And when we're multiplying fractions, we multiply straight across the top, straight across the bottom. So y equals, a little bit of side work here, negative 3 over 2 times 2 over 1. These guys can cancel out, cross-canceling, and we're left with negative 3 over 1, or just negative 3 plus 2. So that's going to give us negative 1. All right, let's do it with this one. Y equals negative 3 over 2 times, this time it's going to be negative 2 over 1 plus 2. Again, we can cross cancel here, and a negative times a negative is a positive, so we now have y equals positive 3 plus 2, which is 5. Okay, now that we have that information, let's go ahead and graph these points. The first one, we're going to go over 0, up 2, and then we go over 2, down 1, and then we go over negative 2 and up 1, 2, 3, 4, and 5. And sure enough, you can see that this is a line forming. So take your straight edge, you can fold a piece of paper if you need to, and draw your line, and there you go, you have just graphed your line. All right, let's take a look at the next one. So for example number 6, graph y minus x equals 0, and it says to solve for y first. So I'm going to add x to both sides. So that gives me y equals x. Well, that's easy peasy because whatever y is, x is that, or whatever x is, y is going to be. So if I plug in a 0 for x, y is 0. Plug in 3, I get 3. Plug in negative 3, I get negative 3. Easy peasy. 0, 0. Then we go over 3, up 3. And we go over negative 3 and down 3. Again, we're going to graph those guys, right? Or we're going to draw the line with our straight edge here. Kablam, kablam, just like that. And there you go. You have just graphed that guy. Okay, so let's take a moment to do these practice problems and then come on back. So pause the video, do the practice problems, come on back, and then we will talk about those. Okay, so we are looking at this first one. Represent this as a set K. So we're going to say K equals brackets 0 and then a 1, and then a 3, and then a 5, and then 95, and there you go. That's supposed to be a 5. It's kind of weird. All right, looking at part B, or question B, you're going to answer true or false. Is 5 included in B? It is, so that is true. Is 5 not included in C? That is correct, it is not. Is 0 included in A? Yep, that's true too. Is 3 not included in C? Oh, nope, it is included, so that is false. Okay, graph this guy, solve for y first. So 2x minus 3y equals 6. To get y by itself, we're going to minus 2x from both sides. So now what we have is negative 3y equals negative 2x plus 6. Remember, it could also be 6 minus 2x, but we want to put the chunk with the x in front of the loose number back here. And be very mindful of your signs. It's negative. We're minusing 2x. It's negative 2x plus 6. Okay. Divide this by negative 3 and divide each of our chunks by negative 3. When I do that, I get y equals, now remember, a negative divided by a negative is a positive. So we're going to say 2 over 3x minus 2. 6 divided by 3 is 2. Okay. So now this time it doesn't give us your x and your x that you're going to plug in, your domain, right? Or your input. So we have to pick our own, and you want to be very careful when you do this. You want to, if you see that you have a denominator of 3 here, you want to pick things that are multiples of 3, because if you pick something that is not a multiple of 3, you're going to have a fraction, and fractions are pain. We don't want that. So let's pick, for example, negative 3, positive 3, and then 6. All right, so if we have this, we have y equals 2 over 3 times negative 3 over 1 minus 2. I automatically put it over 1 because I'm dealing with fractions. So y equals, now a positive times a negative is a negative. The 3's cancel out, and we're left with 2 over 1, which is just 2. So negative 2 minus 2, remember, add the opposite, and we get y equals negative 4. Okay, so then we have y equals 2 over 3 times 3 over 1, because now I'm doing this 3 here, and minus 2. Oh, my nose itches. Oh, allergy season. All right, cancel out our 3's. We get 2. So 2 minus 2, which is 0. And then let's do this other one. Y equals 2 over 3 times 6 over 1 minus 2. Divide by 3, we get 1. Divide by 3, we get 2. So that gives us, upstairs we have 2 times 2 is 4. Downstairs it's 1 times 1 is 1. So 4 over 1 is just 4 minus 2. So y equals 2. Okay, so let's go ahead and graph this guy. So we have negative 3, 3, and 6, and then we have negative 4, 0, and 2. All right, let's clear that out of the way. So when we do this, we have, just like that, we go over negative 3, 1, 2, 3, and down 1, 2, 3, 4. Then we go over 3, up 0, 3, up 0. We go over 6, up 2. And sure enough, you'll see that that line is starting to take shape there. Can't draw. There we go. Schwank. And there is our answer. If you have any questions, leave them below. Otherwise, great work, and we'll see you next time.